Hi everybody, I'm the Greatest Living Inventor, and today we are doing my invention about hot mirrors. Okay, so I'll write it hot mirrors. Okay, so this invention is supposed to help against coral bleach. Coral bleaching. Okay, if you look in Wikipedia, it's coral bleaching. Okay, what does it mean? I'm sure you know, but just if someone doesn't. Coral bleaching is when the corals in the coral reefs, if this is a coral, okay, it's like a tree, and inside the coral, if we look up close, the coral, if we enlarge it, it looks like this. There is a skeleton made of stuff that is like stone, like calcite or something, and here the coral is alive, and it has also a polyp, okay, which is like it's an animal. The whole coral is an animal, and it eats and stuff, but it also has a partnership with the algae. Okay, so this is the polyp. I'm not sure if the polyp is with I or with the Y, so I'm sorry if I got it wrong. Polyp, I hope it's with I. And the algae. Algae is, you know, like a plant. Okay, algae, and they are partners. Like the algae brings 90% of the energy. That the coral uses. Okay, this is like an enlargement of every small part of the coral. Okay, so this is like zoom in. Okay. Okay, so when the sea temperature gets hotter, rises, then the algae starts to make some, it makes photosynthesis normally, but then when it's too hot, it gives also some kind of oxygen that is poisonous for the coral, for the polyp. Okay, this is the coral, and it like rejects the coral rejects the algae. It gets it out. Okay, so instead of this, we have the algae outside. So so the algae can no longer give the coral the energy that it used to give. And the coral loses its color. Okay, normally what gives the coral its color, it's in nature they have bright colors, is the algae and the connection with the algae. So without the algae, most of the corals change colors, mostly for being white. Okay, and this is why it's called coral bleaching, because they turn to be white and they die. Okay, so very few corals can survive this if the conditions return to normal, but most of them die. Okay, so so we understood this. And now what can we do about it? Because as you know, the temperature rising of the water is because of us. It's because we produce the global warming. Okay, so I don't need to explain about the global warming. So I hope in the long term we will fix this, but what can we do now to save the corals? Because there are patches of corals, there are big areas of corals, like in the corals of the Great Barrier Reef. There are thousands of kilometers, like 2,000 of kilometers, 2,000 islands of corals. But if we want to save the parts that are the most precious, like small spots that have the most biodiversity, that have the most species living in them, it's in the coral triangle. Okay, the coral triangle is between Solomon Islands and Papua New Guinea, and the Philippines, and the east part of Indonesia, and of like Borneo, and because even part of Papua New Guinea is of Indonesia, and you can look it up in Wikipedia. It's the place where the most rich place in the world in species of corals. This is like the most biodiverse reefs. Okay, and we cannot use this solution to cover all of it because it's big, but we can save specific spots that are the most rich, okay, in species. Okay, so what is this? And also, one second, I pointed for you this cover, the box of a movie that is about preserving these corals. It's called The Journey to the South Pacific. Okay, it's I'm about to see it, like I will download it today and will watch it, and it's with it's narrated by Kate Blanchett, okay, from Lord of the Rings and The Hobbit. So you should see it. I'll see it today. And okay, so we understood what we want to do now. How are we going to do it? So the solution is really simple. You just need to know about it and to use it to apply it there. It's called hot mirror, and hot mirror is in photographing. Okay, if you have a camera, like if let's say this is a camera, okay? And okay, this is my attempt to draw a camera. So in the lens, okay, the lens has a filter. Now, what is this filter? The filter prevents it from getting too much light. And when we say light, we mean light in the near the infrared, okay? So it's like the hot light, okay? Not like, I'm sure you know that the colors of the rainbow, like we have red, and we have orange. I don't have all the colors, so you will have to imagine some of them. And light green and green. Okay, I'm not drawing all of them, but this is, let's say this is purple. And here we have colors that we can't see, like ultraviolet. And here we have, also we can't see it, but we have infrared. Okay, so the filter, what the filter does is it takes out the, oh, and by the way, it's important, infrared is heat. Again, I guess you know this, but just to make sure. Infrared is heat, equals heat. So it's the actual heat that we can feel. It's also in our remote control, but it's basically the heat. If we feel heat in our body, or coming from the sun, it's infrared. Okay, so the filter takes this and doesn't let them pass. It reflects only these colors, the near red. Actually, it's more like the near red, because we want the red, but the near red and the infrared. Okay, so this is what the filter does. This is the hot mirror. If you want to know exactly how it works, I recommend there is the mechanism of how it works is called the thin film interference, and it's explained in a YouTube video, really beautiful to see, and also it's interesting. It's called Thin Film Interference and the Beauty of Soap Bubbles by Bryan Rolfe. Thin film interference and the beauty of soap bubbles. And it's by Bryan Rolfe. So when we use this kind of filter, this hot mirror, this is why it's called hot mirror, because it reflects the heat. When you stand in front of this mirror and there is light, the light passes and the heat reflects back, so you feel the heat. So for photography, it needs to be small and accurate. So it should give exactly the light and not distort the light. But for the corals, we don't need such, we need it big, and we don't care about the accuracy. The coral will be happy with this light, for example, or only this light too. They will survive much better than if we leave them the way they are. So we should just use this kind of thin film interference and make okay. So if we have some patch of a hotspot of biodiversity, let's erase this. So let's say in here we have some corals, and here's a fish. And with bubbles, okay, and this is the sea. All this is under the sea, and it's close to the surface because it's always not deep where the corals are, because they need a lot of sun. There are deep sea corals, but deep sea reefs, but they are special. Like most of the corals that we talk about and we see in the movies, and that we talked about in coral bleaching, they are near the surface. So we put, let's say this is a few dozens of meters. We put poles into the ground of basically into the sand. Okay, here is the sand beneath the corals, the ground. Sand. and we make like a shade. It's basically a shade, but a shade that lets the light come in and reflects the heat out. Okay, so we have another pole, and here we have with two other poles we have a shade. And this shade is we put it's basically we buy from the same companies that make this, but in specifications that are less accurate, so they are cheaper, but more bigger, like have bigger surface. So all this will be covered with surfaces of hot mirrors, and when the sun comes in, okay, let's make the sun in red because it's like the heat. So when the light of the sun comes in, it goes up and reflects away from the corals. It doesn't get to the corals, but all the light, the good light, does come in and feeds the corals, and they can have their algae, and then they can live happily and not get bleached. And that's it, basically. That's my invention. So I hope it was clear, and I'll see you in my next invention. So thank you very much. Goodbye.